Because of the lack of gravity, space offers unique conditions for developing technology and performing research. Amazing accomplishments have been made at the ISS, like advanced medical instruments, new materials, and water purification techniques.
Historically, that type of activity in low Earth orbit has been reserved for large corporations and companies with close to unlimited resources. And that is where today's guest comes into the picture. Veronica La Regina is head of European operations at Nanoracks in Torino. And they are on a mission to democratize space.
My name is Susanna Levenhaupt.
My name is Marcus Pettersson.
And this is Have We Gone to Mars Yet?
Space is opening up, and every launch full of payloads is pretty much one step closer to that Mars mission we are so excited about. Today we get to talk to someone who helps making space accessible to everyone.
By organizing for research groups to fit their projects on NASA's commercial resupply service rides that go up to the ISS on a regular basis, Nanoracks can offer an end-to-end solution with a much smaller price tag than booking a ticket on a rideshare mission. In that way, they sort of pave the way for more discoveries and development that perhaps wouldn't otherwise have been made.
We met up with Veronica in a park in Torino to learn more about their operations today and also what wonderful things that lay ahead. But first, Veronica, tell us about your company, Nanoracks.
I am leading NanoRacks Europe, that is based here in Torino. It is the sister company of NanoRack LLC, based in the US, that started more than 10 years ago. Actually, we choose Torino because in Torino has been built more than 41% of the International Space Station. And this station, it is basically our home outpost in LEO orbit. Why? Because NanoRack has been invested more than $40 million in instrumentation and capability to host commercial-driven payloads. And so far, we succeed to bring up to space more than 1,300 payloads. We bring things up to space without having a rocket. So this helps us basically to have a lean approach in a way that we do not have too much cost and we can go in front of a customer with affordable conditions. So it means that they are not prohibitive. That's why we pursue the democratization of accessing space. So basically when we receive an inquiry or we are inducing a needs to customer to go up to space, the conversation starts, okay, what you would like to do in space. Sometimes the conversation is taking a little bit long. Sometimes it's very short straight away because there are customers already in a certain way educated to space and customers, they are excited about space. They would like to get the best of space and we help them to define their mission objective. After we said, okay, you would like to bring this item to space and needs to have this constraint, thermal, taxi condition to go up to space, shaping, packaging, preparing, making sure that is not to create any hazard to the station or to the crew member on the station. We organize all these things for making it happen. So one big part, it is the safety review. Basically, we need to make sure that is getting approval to go up. Then there is the matching to be operated in space within our facility from our mission control center. And then we make sure that we are going to deliver to the customer what the customer is expecting to have.
How much interaction do you need from the actual astronauts working at the ISS?
We know very well that the astronaut can be very busy and they may have a limited time for supporting this type of activity. So one trend of our ConOps has been to making everything autonomous as much as possible. Then there is the fun part that every customer would like to get a picture of their toy in orbit when the astronaut is operating. Fine.
Can a customer send anything they want up to space?
TIL is not creating a damage to astronaut and to the ISS as an infrastructure. It is the first requirement to set. Then on board of the International Space Station, because we work under the NASA Space Act Agreement, we have two venues. One, it is the advancement of education, science and technology. So we get the merits that the result, they are going to be delivered and making available to the whole community, to NASA as well. So in a certain way, NASA is welcoming to do this activity because everyone is getting a gain. The other venue, it is the commercial policy from NASA. So basically, if you would like to send something up to space and the requirements of science advancement, technology improvement are not met, then there is a policy of NASA that requires the refunding of the ISS resource. There is a published pricing policy from NASA. So on top of the work to be done, we have to refund this ISS resource up to NASA, and this makes the price increasing. So in principle, you can do whatever you want. It's a matter of how much is going to be affordable for the customer.
Let's say I have a company. I would like to send something up to do an experiment. It needs to be there for 3 weeks. And in 3 days, you have to turn it over, and then you have to open it and look at this thing, and then you have to move that. So you take care of the whole process.
Yes, correct. It's an end-to-end services. We start this business considering the U factor that is coming from the CubeSat. So this box, modular in shape, starting from 10 centimeter up to a certain capacity. So we have capacity internally, externally, can be very small, can be very big. So for instance, on the Bishop Airlock, it is our last, more complex capacity. We can host a payload of 100 kilos. That instead in the previous facility that we still have operating on the station, they are much smaller.
Tell us about Bishop and why is it called that?
The Bishop, the name came from the chess. So it is this character that is moving on the diagonal instead to be vertical, horizontal like the other one. And this give us the opportunity to have a capability that really can make a change because, first of all, has the airlock capacity, means that has the ability to transfer the payload from a pressurized environment of the station to the unpressurized environment outside the station, or vice versa. When they are hosted outside, they need to retrieve it back. Then, we have the opportunity to host big payload in terms of 100 around the rings of the Bishop externally. So it's big one. You can look up to the universe. You can look down to the Earth if you put a camera or a detector sensor, whatever you would like to do. On the other side, when it's opened, you can inject satellite of 100 kilos and not only just CubeSat, but big satellite. Then never forget that when it is closed, it is an empty room to do additional internal research, particularly for that activity that they need maneuver, like robotic arm and so on, that you cannot do in the station because it's crewed, because it's instrumented, because there are activities are going on.
Who is it that comes to you? Who are your customers?
Our dream is that everyone can come to us. Like you take a plan to go to London and you don't have to give any justification, we would like to have a day, the opportunity to bring the dreams of everyone to go up to space. So far, I can say that there are primarily 3 lines of customer segmentation. That is school, education, science, primarily university and academia, and technology. So there are a new startup company that they open up their technology for space purpose. They would like to test for the first time, and they come to us how they can go up to space, test their technology, and retrieve it back, because the station is served to go up, but also to come down. And then there are a number of emerging companies that actually they are not doing nothing to space. They just use space as a big lab. So particularly for plant germination, for new packaging material, for new material for radiation shielding, is so vast. I mean, the number of spin-off of technology came from space exploration.
But do you have unlimited capacity, or do you turn projects down?
We have capacity enough to match the customer needs currently. Of course, we are hosted on a project that is initially in an intergovernmental orbital platform, that is the International Space Station. So we have agreement with NASA to do certain things, and we need to be compliant to these constraints. So far, they have been generous enough, and also we came with the innovative concept of operation to drive the customer needs to meet their challenge. So it's a mix. I mean, we should not forget that constraints, they are a good engine for innovation.
What are your plans for the future? Do you have any other missions or other things you want to do in space?
I mean, doing this activity since more than 10 years point out a number of, let's say, limits. So new challenge for the next. So one of the limits that we experimented on the station is the quality of microgravity. So the quality of microgravity means to have a uniformity of microgravity, particularly when you do production in orbit. You know, you are generating 3D printing materials, tissue engineering. All this activity, they require a uniform quality of microgravity. That on the station is missing for a number of reasons. You have the astronauts, they are going up and down, jumping. Then there is the normal decaying of the orbit. So every time a vehicle is going up, then it's boosted, the station move. So the gravity condition, the microgravity condition are disturbed. That's why we get a really fun attention to the free fly opportunity, where you have a module that you can keep station the quality of the microgravity. And then we understood that there are a number of customers that they just would like to go up to space. They would like to have more freedom in the way they go up to space. That's why we matured the idea to have our own space station. And we came with the idea of the Star Lab. If you can see, I mean, has been recently awarded by NASA to move forward the plan. And basically, it is a sort of satellite with a service module, so a technology that is reliable enough. And then there is an expandable module, is inflatable. So basically, it can be crewed since its injection. This means that with one launch, we are going to have a crewed space station. Instead, historically, all the space stations have been set with a number of launch. First the service module, then the habitat, and then the research capability, and blah, blah, blah. So you need many launch. This is the challenge in front of us. We are working very hard for making this happen, and we hope it's going to be.
First off, it's so cool that you're going to build your own space station, but if everything goes as planned, which it never does, but if everything goes as planned, when will Starlab be operational?
The ambition is to have the launch by 2027 to assure a smooth transition from the ISS to the new station.
You cannot build it by yourself, so who are you working with?
Yes, the plan in front of us is that NanoRack is the prime, and we set the opportunity to be the prime because we know very well the customer needs, so we can drive the type of technology solution needs to be set. And then on this endeavor, we are working with Lockheed Martin and with Voyager Space. At the same time, we are still looking for a number of partners for making unique, not only in terms of structure of the mainframe, but also in terms of outfitting capability to perform the experiment, to be flexible and agile enough. So I would say that the business is still open.
Are you looking at taking experiments to the moon or maybe even to Mars eventually?
The moon I would say that is one of the proudness of NanoRack Europe. We are starting to position ourselves for the moon in a number of activities. So we are partner of the Italian consortium that is going to deliver the moon shelter, that is the Italian contribution to Artemis. And NanoRack Europe is leading the definition of the Lunar Lab, so to create a science corner to perform experiment. And we are doing this having in mind the same business model and the same frames that we have been proven to work on the station. This gives us the opportunity to easily propose to our current customer base to move from the ISS to the moon. Then, we are involved here in Italy in a number of projects related with the setting up of the lunar communication and navigation system with ESA. The initiative is called Moonlight. And for this, we have the opportunity to work to define a commercial-driven tiered payload hosted on a satellite orbiting around the moon. So maybe beside the primary mission for communication and navigation, customer would like to have a camera to have a recurrent the image acquisition of the moon. Another project is the sintering procedure of regolith simulant, so it's still on ground, to basically put the simulant in a microwave and to deliver bricks. So these techniques, for making it simple, basically you have the opportunity to produce bricks without using water. That is definitely a matter of scarcity on the moon. Still many things to be done, but quite exciting to think about the moon. Mars. I like to define myself a Mars generation, but I would say the path to go there is still long. I think it's a good goal to have in front of us, to work for it. As a company and personally, I did not identify a path, but I'm making myself awake at night to think about.
Inspiring times ahead for sure.
Definitely. And I love the thought of opening up for more research in space, which might lead to a lot of solutions to the problems we deal with on Earth. Like those bricks Veronica talked about. That research could provide great insight to how we can build water-efficient constructions in dry areas, even if those areas are not on the moon.
And it's good to know that there will be a space laboratory out there even after the ISS is disassembled. NanoRack's Starlab is proclaimed to be the world's first science park in space, and I can't imagine a more attractive place to perform one's research.
Looking forward to the future. But now it's time to say goodbye. My name is Susanna Levenhaupt.
My name is Marcus Pettersson.
The music we play is composed by Armin Pendek.
Have We Gone to Mars Yet is produced at Beppo by Rundfunk Media in collaboration with Rymdkapital. Read more about them and how you can get yourself involved at havewegonetomarsyet.com.
Hallo, Programmet gjordes av Rundfunk Media.